All right, Karl Popper, one of our favorite philosophers. Not okay. Um, again, from Karl Popper, The Problem of Induction, so-called, from tamucc.edu. Put a link to this again. Put a link to before. So, as he says, Section 3, Deductive Testing and Theories. So he's claimed that the quote-unquote problems of induction are insurmountable. And some of the stuff is really empirical psychology, not logic. Okay, and it's a bunch of nonsense. So he says, quote, according to the view that will be put forward here, the method of critically testing theories and selecting them according to the results of tests always proceeds on the following lines. From a new idea, put up tentatively, and not yet justified in any way. And go, like, what the hell is that supposed to mean? As I said before, that's just making crap up. You know, that characterizes the nonsense that's pseudoscience. That is not science. Marxism, elements of Freud, a lot of racism, Nazism, and some other things in science that are a little more than not justified in any way. But, he says, I mean, this is like imagination. This is fiction. You make crap up and then you write a story about it. That's telling fiction. That is not science. Look at what Galileo, Newton, Darwin, Marie Curie, and others actually did. James Joule, mathematicians. They don't have a new idea, put up tentatively, not yet justified in any way. That's crazy. No, you have justification for what you think. There's to be possibility or probability in truth, in experience, in which you've already learned and known. That's how knowledge works and science works. It doesn't come out of nowhere. Okay, and he says, from a new idea, put up tentatively and not yet justified in any way. Conclusions are drawn by means of logical deduction, unquote. And again, that's BS. If he's going to separate experience from things like that, and you're not going to have induction, and you're not getting how knowledge really works, I don't think so. Logical deduction depends on experience too, as we said. And as the facts say, deduction is parasitic on induction. You give up on induction, forget your deductions. You ain't got them. There's no context, concretes, causality, anything. It's empty. Then he's talking about meaningless statements. And if you get something like that from an idea put up arbitrarily without evidence, that'd be like trying to work with a language you don't know. Can you deduce anything, logically deduce in a language you don't know? Obviously not, because in that case, we don't know what the hell we're talking about. Just like this. Take dogs and squirrels are mammals. Do we deduce that? No. Only someone who doesn't know how the hell knowledge works, someone who's crazy, some little goofy kid who doesn't know how to think yet. We're all that way in some way or other when we're young. None of us are omniscient and geniuses. You can be a genius in math, great violinist or whatever. There's child prodigies and stuff like that. But chess, but in philosophy, no, never have been, never will be. just because of the nature of the field. It takes more introspection. And before one can introspect, one must have content. You got to learn about the world, and then you can start learning about your learning, so to speak. You got to be aware of the world, and then you can start being aware of your awareness. Emotions, love, relationships, governments, friendships, science, failures to think properly and all this and act. So, you know, logical deductions immersed in experiential content. There's got to be material content to it. No one ever knows that a dog and a cat are mammals without learning it from experience. You know, you learn dog, you learn cat when you're young, and then later on, with more advanced learning, a lot more concepts involved. Reproduction, milk, mammary glands, all this stuff. Then, in knowing about the different animals and studying them and seeing that it's factually the case, we learn it from experience. Then we can see that they're mammals. And I'll put a quote in that regard from Galileo too, something I talked about before. Experience gives us all kinds of things we never could have imagined. Something like that. Or we can't know by logical deduction. No one ever figured out that electricity and magnetism were different versions of the same thing by logical deduction. That wasn't some idea put up tentatively, not yet justified in any way. Oh, electromagnetism. No one ever. I mean, that shows a just deep misunderstanding or ignorance or evasion or whatever of how science works. Look at how people learned and how they knew that electricity and magnetism were different aspects of the same thing. Look at the facts. If people would quit getting lost in their heads, some of these people, if they would look, what in reality did scientists have to do to figure out the theory of electromagnetism? Then we wouldn't have all this nonsense, misleading people, having philosophers, some philosophers all cray-cray, some scientists like disillusioned about how they're actually doing, they think they're doing things versus how they're actually doing things. There wouldn't be all these confusions, poor ideas about education, about science, scientists not being educated properly. You know, a mistake or a lie is not cost-free. There are consequences and implications. So, quote, these conclusions are then compared with one another and with other relevant statements so as to find out what logical relations exist between them, unquote. Like, how? Without looking at if things are similar or different, things in reality and what we know about them. This is nothing. This is empty. Again, try to do it with some language you don't know. Here's Chinese, which you don't know. Show me the logical relations between what they're talking about here, or between stuff you don't know about. Give me a different language, something you don't know about, some field. No. This ain't ever going to happen. This is just some fantasy. This is pseudoscience. So it's funny that, unfortunate, in Popper, he might have been a decent guy. Maybe he was trying to figure out some things. It's good he wanted to distinguish between science and pseudoscience. But, man, this is sadly just a total failure. You cannot have logical relations without knowing the facts of things. You know, again, like electricity and magnetism, there ain't no logical relationship you can figure out to know that they're different aspects of the same thing without experiment and experience and getting concepts and generalizations step by step from the evidence of the senses. No way. So, you know, if we look at like a basic deduction, like all dogs are mammals, domestic dogs. All German Shepherds are domestic dogs. Therefore, all German Shepherds are mammals. How the hell do we know that there's German Shepherds? No one ever in reality is going to conclude that without knowing they're German Shepherds. I didn't know there were German Shepherds when I was young. No one ever does until you learn in reality that there is such a thing. You don't conceive like Kant might have fantasized like you could, or Descartes. Oh, I can deduce that they're German Shepherds. Bull squat, no one ever. I can deduce that they're rabbits from oxygen. Bull squat, no one ever. From oxygen to deduce rabbits, that's a fantasy. That is like delusional. You've got to know that they're rabbits to know that they're rabbits. As Galileo said, he had it more right. Experience is full of more variety than you could ever imagine. Our knowledge and our ability to be creative is very limited. We got to look at experience to see more things. But I would never imagine that there was some beautiful, strong, gorgeous dog that I just love to hug and pet and feed raw beef like a German Shepherd. I would never imagine that without knowing it from reality. Once we do that, then we know what German Shepherds are, we know their dogs, and we know their mammals. It's wrapped up in experience. How do you classify things? How do you know that some group, some things are similar and of a kind with some other things? It's not pure deduction. It's by looking at reality and observing facts, traits, characteristics, actions, similarities and differences, and grouping and seeing. Dogs are mammals. Right triangles are triangles. Triangles are polygons, things like that. It's immersed in what we have learned from experience, conceptually and inductively. You can't get away from that in doing science. Otherwise, as I say, it's empty and lost. Nothing. You can't make up some idea. And besides, we are limited and finite. The only thing we have available to make up ideas is the content we already have in our minds. There is no other stuff we can work with and put together to imagine something. Everything, if you look in human history, all stories, there's never anything that is sui generis, that has no relationship to what people already know. You know, unicorns, zebras, horses, animals with horns. Put them together. Or mermaids, a person, a dolphin or something like that, something with a tail, put the things together. Some kind of dragon, big lizard and stuff like that. There's never anything that has no relationship to what we've done before. So this is kind of like goofy anyway. You know, we have to use what we already know to make up new ideas. And, you know, it's not inconsistent with what he's saying. He could agree. Yeah, I agree. But where he says not justified in any way, no. That is not the way science works. We have things, you know, and if we're doing like that, I mean, there's no stop. Just imagine the time people are going to waste making crap up and trying to, like, deduce conclusions from it. What a waste of time. Did Galileo or Newton did that? No. Darwin? No. What you do, as Galileo said in some things, you immerse yourself in experience and identify what's there. Things are justified in a way, and then the more they're justified, the more you know it's true when you start connecting and seeing if it's right. So there's one thing that is really wrong with what he does. So he's lost and pushed into this corner where I don't think he's even quite getting what, like, logical deduction is. And, you know, still, it's like, that's just a waste of time. When you want to be going out and being around dogs and seeing what they're like and not sitting in your room making up ideas. You want to be going and observing things. Oh, there's something new. What's going on? What is the thing? Why is this happening? That is how one will do science. Or go around horses and observe them. Think about what they're doing, why, lifestyle, survival, motion, social aspects, behavior, grooming, communication, training the young. Go out and immerse yourself and observe and start to find similarities. You see something happen again and again and again. Oh, we'll form a concept of that. We'll have a generalization. That is how you're going to do science well. Doing that, notice if we have something proper like that, that's going to be a totally different, that philosophy will have totally different implications about how we do, teach, do science, teach science, train scientists. Much more effective when we teach them to think and observe than to like go somewhere and just make a bunch of crap up and try to deduce deductions. Make stuff up and test it. And then, even then, if we're not finding necessity between a generalization and specifics, if you give up on that, so we can't, it's just the problem of induction, like the problem of a digestion, the problem of a deduction. And then, you know, there's a problem of deduction too. If he was more aware, more honest, more historically aware, knew more about development of philosophy and stuff, he'd know this more. I don't know what the deal was. I have no idea. Have to dig into his work more. So much as I have time. So much to do, so little time. He's only worth so much. But, and then it might just be, you'd have to talk to him to see, get an answer to some questions, but that's no longer possible. But, you know, there was a problem of deduction too. It's just that, and there still is, as I said, people make a lot of mistakes with deductions, but Aristotle has figured out the rules of a deduction, the basic atom or element of a deduction, a syllogism. That's a basic part of the argument. And he figured out, he and some others, what all the basic syllogisms or little deductive arguments were. And he identified the basic principle in them all. He generalized, unlike what Popper, unfortunately, doesn't do or is scared to do. He's got some misinformation. It's pretty sad. I wish he was better educated, and so he didn't have that, make that mistake. But what did Aristotle have to do at his time, which was not done? He had to look and see that, in all these syllogisms, what do they have in common? How they differ from the ones that don't work? So there's these that work, there's these that don't work. Like all dogs are mammals, all squirrels are mammals, therefore all dogs are squirrels. It's a deductive argument, but it's invalid. As opposed to all dogs are mammals, German shepherds are dogs, therefore German shepherds are mammals, which is legit. And notice it's rooted in classification in the nature of things, in how we classify, how we know things. There's this element of classification in there, similarity and difference involved, forming concepts, how we form concepts and all that, how things differ in measurement, the more and the less, how they differ in, because dogs have a different range of heights than other animals, different range of lengths than other animals, locomotion, speed, acceleration, dietary preferences, hunting strategies, reproductive strategies, things like that, eyes, nose. Strength of smell, strength of using one sense more than another, how they use hearing and all that. But that stuff is wrapped up and we get from experience. And, there's would still be a problem of deduction if it weren't for Aristotle, again, identifying what these things are, the different syllogisms, rules for deduction, the fact that when you have a bad syllogism, it's like you're contradicting yourself. Oh, look, in these cases, with these deductions, these good ones, we're staying consistent. We're not saying one thing and saying another. We're not claiming one thing's true and then claiming something else is true. So non-contradiction. With some others, we're saying one thing and saying another. Dogs are mammals. Dogs are not mammals. All dogs are mammals. All dogs are not mammals. Whatever. There's, let's just put a contradiction. And so we know that, and we have rules for dealing with it, and we can measure things out, assess the worth and validity and truth of some deductions, of syllogisms and longer arguments. But that doesn't mean we're omniscient. Doesn't mean deduction is perfect. You go back in time, and you see that people didn't know how to determine what was a good argument, what was not. When ancient people get together, they're discussing some course of action. How are we going to deal with this other tribe? What are we going to do about this drought? They're talking, trying to make a decision. They didn't really have yet know about good logical scientific standards for assessing their arguments. They just go by kind of plausibility or what made sense at the time, do the best they could. Ancient Greeks would argue a lot, and there's arguments over courses of action that peoples and governments have made over the past, several thousand years, millennia. But, we know that there are rules for deduction. And so people still make mistakes with it, but we know what to do. We just haven't figured out what some of those are for induction, but that doesn't make it invalid. Or as I say, at one time there was the question whether heliocentrism is justified or under what conditions is known as a problem of astronomy, the problem of heliocentrism. Nonsense. We know that the Earth goes around the sun now, but there were problems with it as one time, and we had to figure it out. Same thing with this. As I've said, we need to figure out what makes induction correct and not claim there's an insurmountable problem. At one time people would say there's an insurmountable problem with heliocentrism, but it's just, it wasn't insurmountable. It may be for you, but not in principle, in logic and in philosophy and in human knowledge. It is not insurmountable there because we've surmounted it. Same thing here. This is not insurmountable. It's like on principle for everyone metaphysically, epistemologically. It's just insurmountable for some people. And so what we need to do is be like Newton, and to surmount some stuff, we need to stand on the shoulders of giants. That's what I did. There's no way in hell I could surmount it on my own. But standing on the shoulders of giants who stand on the shoulders of giants and letting them go over it, then we get there. But so there was at one time, a problem of deduction, a problem of argument. How do we know? Or a problem of heliocentrism. When we're thinking about this, we should think in principle. A problem of induction. Okay, well, how would this relate to other things? Is this only for induction? Is this really? Is it obvious? Have humans always deduced properly? Do they always know the rules of deduction? Obviously not. It took millennia for humans to exist for millennia until someone finally figured out how to do it correctly. And then clearly not everyone does it right. Or to know about heliocentrism, as I say, or proper theory of government, or the theory of electromagnetism, or the atomic theory of matter. Took a while. This is a scientific problem also that needs to be worked out, not armchair philosophized about and stuff like that. People can't make up a solution, you know. Part of the problem Popper and others have with induction is that they're not digging into the history of philosophy, seeing how people actually induce things, knowing that they did, what made them certain, what made them able to go through so many leaps and jumps. And I don't mean like jumping to conclusions like the logical fallacy, but I mean solid, established, good inductions and generalizations. So induction is all right. As you can see, we got to learn more about it. But here, if there's a problem, kind of going back to, you know, as we develop that thought, now, remember I was talking about the relationship between singular and general statements. If induction feeds deduction, without induction, your deductions are failures. They're empty, there's nothing. They do not, generalizations do not exist. So in some way, as I say, you got intellectual grand larceny here. He can't be doing all this deduction stuff without induction in the first place. You got to have generalizations that have meaning to them. They've got material meaning. They're classifications of things in the world and their cause-effect relationships. Otherwise, there's nothing. You're just making stuff up. It's just fiction. But if there is a problem with the relationship between generalizations and particulars in the first place, then he cannot go back later and say that we deduce consequences and then test them in practice to look for singular statements. No. You cannot go back and claim that causal connection if you're going to deny it in the first place. So, because he says, you look for logical relations between them. The one thing he's saying here, okay, so, quote, we may, if we like, distinguish 4 different lines along which the testing of a theory could be carried out. First, there is the logical comparison of the conclusions among themselves, by which the internal consistency of the system is tested. 2, there is the investigation of the logical form of the theory with the object of determining whether it has the character of an empirical or scientific theory, and whether it is, for example, tautological. Thirdly, there is a comparison with other theories, chiefly with the aim of determining whether the theory would constitute a scientific advance should it survive our various tests. Finally, there is a testing of the theory by way of empirical applications of the conclusions which can be derived from it, unquote. Okay, now, if you have a theory, something that is general, and you get a particular to test it, and you claim that one thing contradicts another, no, you cannot have that, because you're denying the relationship, the necessary relationship between particulars and generalizations in the first place. And so you cannot claim that it's purely deductive and separate from that stuff. If you got all S is P, or S causes P, something like that, and then you have this particular thing, which you claim contradicts that. Okay, sorry, there's no necessary relationship between this and this. You can't say it necessarily contradicts it. Because inductions aren't valid. It's probable or possible, but not necessarily true. You know, how do you know what the relationship is between this and this? Did you miss something? What about others? Remember, because he says something about enumeration, and we can't. But he says up here, no matter how many instances of white swans we may have observed, this does not justify the conclusion that all swans are white, unquote. Okay? No matter how many contradictions to this you may have observed, it does not justify the conclusion that this doesn't apply to all things or some others. So, the question whether inductive inferences are justified or under what conditions, blah, blah, blah. Okay. So basically you're going to deny the connection. We can't get a generalization from particulars, so how can you go back and apply a generalization to particulars? What's the connection? If there's no necessary connection, there's no necessary connection. It's not necessarily connected. Are you really looking at the right thing to say that this doesn't go with that? How do you know? How do you know that these don't go together unless you know what it is for a generalization to be logically necessarily connected to a concrete thing? That basic thing is being denied, and then he goes back and tries to use it. Intellectual grand larceny. Be interesting to see what he might say to respond to this. But, there is where we have an insurmountable problem, because it's a contradiction. Again, like, you got this thing that's claimed to contradict this. How do you know? We got to be able to connect these things and know what it is to connect, to compare. You can't say it doesn't work. You got to know some generalizations work, some do not work. How do we know it's this one as opposed to this one? We got to know that there are some generalizations that work to measure this situation by. How do we judge it? How do we assess it? How do we see that we classify this here and not here? This and this would have to be known and understood in the first place. But if we're going to deny that some work, you can't have it. You can't have that classification. You can't have, and if you're going to deny necessary connection, you can't claim there's a necessary connection here. It's just maybe. I can't deny it. That's what he would have to say if he was consistent. I can't deny that I can't deny it. He can't say it's true. Because we got this, and like his alleged white swan thing, how do you know that something else is going to come up and so that it's all of a sudden true? It's false, it's true, make up your mind. So, there's another problem with this thing. What he needs to do, as I said, is figure out, if you say all redheads are hot-tempered, invalid, that's one that doesn't work. All planets orbit the sun in elliptical orbits. All planets orbit the sun in elliptical orbits with the sun centered at one focus. Valid. All redheads are hot-tempered, invalid. Just like valid deductions, invalid deductions. Valid inductions, invalid deductions. We need to look at them and classify them and study them like scientists, not just make stuff up. If all swans are white is invalid, well then look and see that it's why. Because there's no causal connection. It's just an enumeration. Here we have a causal connection. We got the sun doing something, causing something, affecting the planets, which is not totally understood, but we know that something's going on. We can measure it and stuff. But here, people have free will. This is denying that. And plus, it denies that some are hot-tempered, some are not. What about other people who are hot-tempered, who are not redheaded, and other people who are not hot-tempered? It's a major denial. So that's more what we need to do. Not the Popperian mistake, nonsense, whatever. I wonder if there's a video of him talking. It'd be interesting to see what it was like in person. But that's something I haven't done before. So much to do, so little time. And so when we look in this, we see he's actually contradicting himself and not getting some things about logic and induction in their relationship. And so all this stuff, this falsifiability nonsense is like a total waste, unproductive, doesn't characterize science, blah, 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 blah. And then, you know, if he's not getting this from experience, it's not true. So even his own falsifiability thing doesn't pass the test of falsifiability. Well, it doesn't, it's not, I should say it's not science. It's more pseudoscience, put it that way. If his ideas about his theory about theories, theory of science, philosophy of science was correct, it would be empirical. It wouldn't just be made up. But then maybe he would say it is because of his misunderstanding of induction and other stuff. Well, I'm making an idea up and then testing it so it fits. But, you know, it's basically what Marxism does too. You know, you make stuff up and test it. So there's delving into induction and deduction in their relationship to show how another place where Popper is wrong. Be good to talk about confirmation too. As I've said before, remember one thing, he's mistaking the idea of confirmation. Maybe I should just make that into another video to kind of like make this more thematic. But he claims that some things are confirmation for Marxism when they're not. Confirmation, verification. Like to say that anything could be a verification is to show he doesn't even know what verification is. It's unfortunate to show, you know, to know that knowledge is an effect of a certain cause. And if the cause ain't there, then the effect ain't there. Evidence has to have some material, experiential, conceptual, logical thought process connection to a conclusion, not just some arbitrary claim. And, you know, in some of these theories, like in Marxism and some other theories of government, they deny free will. And they'd be like a bad deduction. They do not justify what they claim to. There is no real confirmation. That'd be something to dig into also. What exactly confirmation is and evidence. And dig into all this little structure stuff. But we've analyzed this and delved into this enough. Some of these other topics, I say, can be different videos. But as I say, we need to understand induction properly. Good induction, bad deduction. You know, I know nothing's written here, but I'm pointing to what was here, what was here, what was here. All planets orbit the sun, blah, blah, blah. All redheads are hot-headed, blah, blah, blah. Valid, invalid, just like some deductions. We need to look at the facts and see what's the case. Oh yeah, one thing it'd be interesting to discuss is how problematic it is to try to falsify versus confirm. what real confirmation is and how we should spend our time trying to confirm, not falsify. You want to, like, take, for example, confirm that you like someone and you can marry them and not falsify. I like to say, make a joke sometimes. Do you know what the vows are at a statistician's wedding? It's like, I hereby fail to reject this woman as my wife. I hereby fail to reject this man as my husband. Okay, that's what statisticians would say at their wedding. Ha! But that's not what we do with actual science. It's a matter of accepting and knowing something's true and not failing to reject. But, as I say, knowing how induction actually works, digging into it, knowing its relationship to deduction, what can we actually do with so-called deduction and logic without experiential content? We need to know what logic is. He's not getting logic because you can't have logic without that experiential content. Logic is about connecting your concepts and ideas, connecting your ideas and thoughts, conceptual thoughts, to the evidence of the senses. It's having that standard to judge by. Otherwise, all goes. Then, like he says, you just make stuff up without justification. That's not being logical. Where is that? I'll quote that again. Scroll up. From a new idea, put up tentatively and not yet justified in any way. Wrong. No such thing. Real ideas, scientific stuff, are always identifications of something in the real world, a thing, an action, a cause-effect relationship. We put that stuff in conceptual form. And when we can relate stuff to the evidence of the senses, then we're using logic. That's what logic is about, relating it and make sure it's consistent and true. Otherwise, you have no standard and anything goes. There is no logical deduction. As we said, classification depends upon things like that. So, get deduction right, get induction right, then we won't have this nonsense. It'll help us save time in knowing how to do science, how to think. It'll help us assess people who claim they're scientists, who actually knows what they're doing and who doesn't. It'll help us train people better, make education more efficient, produce better scientists. So this is not an ivory tower thing. This is very important. Science is in all our lives. Computer, cell phone, producing cups for coffee, medicine, fitness, vaccines, health, exercise, cars, carbon dioxide, carbon monoxide, radiation, a lot of things. There's no way around being scientific in our lives, so we need to know how to do it well. So let's put it into education, put it into our own thinking, put it into training scientists, and we'll be better. Peace.